Good afternoon. I'm very pleased to be here and talking about this topic and under these circumstances. So my name is Jon Grant, and my title is the NSERC Cook Industrial Research Chair in Sustainable Aquaculture. We're very fortunate in Canada that our national science body, the Natural Science and Engineering Research Council, has a program where they match industries and universities to look at topics of strategic economic significance to Canada. So my chair is with Cook Aquaculture, who I'll talk about in a moment. And if you look at the topics of the research program, which extends over initially 5 years, potentially 10 years, you can see it has some of the topics that Kenny has just talked about, because the interesting thing about aquaculture from a science perspective and also from the Galway perspective is that the issues are the same on both sides of the Atlantic. And in fact, globally, they're the same. The other circumstance is that our species happen to be the same on both sides of the Atlantic, especially Atlantic salmon. So our program has simulation modeling, as Kenny mentioned. We have some aspects on engineering of the cages to prevent escapes, and then examination of waste management, which is a big issue in aquaculture, the benthic habitat health, and then disease management, which was also just mentioned. So the final one, which involves AquaSpace, is marine spatial planning. So how to look at an ecosystem and put aquaculture in it in a compatible way to pursue this EAA, or ecosystem approach to aquaculture. So I'm based at Dalhousie University, which is the premier oceanographic and ocean research university in Canada, with a variety of topics ranging from law and legal policy, governance things, all the way to oceanography, meteorology. And you've heard a little bit about that in terms of MEOPAR and Ocean Tracking Network. I won't say too much about that. But I will talk about Cook Aquaculture, and they have an interesting perspective in this because, first of all, they're the largest domestically owned aquaculture company in North America, farming exclusively Atlantic salmon, with farms throughout eastern Canada and Maine. But they also, in their expansion, have purchased leases and farms in both Scotland and in Spain. So that means that they have a sort of a pan-North Atlantic perspective and ownership, and operate as potential partners throughout a lot of these programs. They also have farms in Chile. And they work in all components of aquaculture, including farming, hatcheries. They make boxes. They have trucking. They do it's end-to-end, or egg to plate, as we say, around the world with Cook Aquaculture. And they're very interested in sustainability issues because they recognize that the operation of aquaculture requires attention to sustainability. So I personally have a long history of EU cooperation in aquaculture because Europe has such strong traditions in this field. And so I've listed a few of my colleagues and the institutions from which they come. The one that's not listed there, which is a really big one, is Norway, but they're a very important collaborator as well. And some of these collaborations go back 20 years, some of them go back 1 year. So I was really heartened about the Galway statement because it means I consider it to be a step change in the way we view these collaborations. So rather than doing ad hoc, they are formalized, and they will receive attention and resources as well. So I think that's a really big thing. But there is a very long history, especially in aquaculture, of EU cooperation. And it goes not just to farmed fish, but to shellfish as well, because the shellfish industry is extremely important in certain parts of Europe. So ecological modeling in aquaculture sites is my research topic, and why do we do it? Why is it worthwhile? And it has a lot to do with scenario building, prediction, and then using those predictions to optimize the way we farm, especially with respect to sustainable aquaculture and ecosystem integrity. So, for example, farm location is a big topic. Where should farms go? How big should they be? And how dense should the animals be cultured? We can answer those kinds of questions. And then how can science help in the regulation? So it's not just helping the industry, it's helping the regulators, and hopefully all those things come together in a win-win situation. You can see in some somewhat extreme examples here of space in aquaculture, so the situation in China where the people are living at the fish farms, and then, but even in the Atlantic coast of Spain, we see that things are compressed pretty tightly in certain areas because desirable places for aquaculture yield more aquaculture in some circumstances. It's very important to manage that. So one of the big issues, as I mentioned, is impacts, and that includes not just around the cages, but in the far field, which means the total marine ecosystem, and then decision support systems. How can we manage these, and how can we make the right decisions for regulators and for the industry? And a lot of it comes down to site selection and, of course, marine spatial planning, which is the topic of AquaSpace. So we tend to think of this in a spatial perspective as a sustainability framework that has the ecosystem services that we are trying to preserve, maintain, and that there are, from a GIS perspective, there are a variety of layers going from society to oceanography, to the environment, to habitat use, and of course, because this is coastal, we end up with a lot of details about the land as well, and river input, those sorts of things. And with salmon, we have wild salmon which live in those rivers. So we try to put those together in marine spatial planning, ultimately to answer questions about the spatial arrangement of those farms, husbandry practices, and pursuing the EAA. Okay. So AquaSpace, we're asking these broad questions, which are the science tools that can be used in spatial planning, and how can modeling and prediction be used to apply this to policy and governance, with the overall arching question of how can we manage aquaculture for sustainability at the ecosystem scale, so not at the near field scale, but at the whole system scale. And just two quick examples, also in reference to what Kenny discussed, which shows we made them independently, but they, the inevitability of the overlap is because the problems overlap. And if you look at a large bay here divided into different segments, we create these connectivity matrices based on hydrodynamic connections and use those for risk analysis. And in another example, I'm showing you a sediment profile image camera, which on the right side is what I call the ant farm view of the sediments, which shows something about benthic health, again, something that can be used for mapping. So we do have a variety of tools that can be used for decision support systems. And our case study, specifically in Nova Scotia, relates to the topic of lobster fishing. So we have extremely healthy lobster fisheries throughout eastern Canada. It's our largest fishery, and there's concern among lobster fishers about interactions with aquaculture, both with regard to pesticide use, space for fishing, etc. So we're looking at planning and GIS-based methods based on the influence of aquaculture and its zonal effects, to try to put those together for, again, for the achievement of healthy ecosystems. And I'm done.